Voting methods. A large number of different voting methods, ways of determining the outcome of such multi-candidate elections, have been suggested. Two of the simpler ones are plurality, the candidate that was placed first by the largest number of voter wins, and vote count. Each candidate among the n candidates gets n minus 1 points for every voter who ranked him in place I, and the candidate with the most points wins. Each of the suggested voting methods has some nice properties, but also some problematic ones. One of the main difficulties encountered by voting methods is that they may encourage strategic voting. Suppose that a certain voter's preferences are A greater than B greater than C for I, but he knows that candidate A will not win and the other voters hate him. Such a voter may be motivated to strategically vote for B instead of A so that B is chosen which he prefers to see. Such strategic voting is problematic as it is not transparent, depends closely on the votes of the other voters, and the interaction of many strategic voters is complex. The main result of this section is the Gibbard-Satterwhite theorem that states that this strategic vulnerability is unavoidable. We will prove the theorem as a corollary of Arrow's impossibility theorem that highlights the general impossibility of designing voting methods with certain natural good desired properties. Formally, we will consider a set of alternatives A, the candidates, and a set of n voters I. Let us denote by L the set of linear orders on A. L is isomorphic to the set of permutations on A. Thus, for every less in A, less is the total order on A, anti-symmetric and transitive. The preferences of each voter I are formally given by greater than I in L, where A greater than B in I means that I prefers alternative A to alternative B. Definition 9.1. A function f which maps from L to the n to L is called a social welfare function. A function f, little f, which maps from L to the n to A is called a social choice function. Thus, a social welfare function aggregates the preferences of all voters into a common preference, i.e., into a total social order on the candidates, while a social choice function aggregates the preferences of all voters into a social choice of a single candidate. Arrow's theorem states that social welfare functions with the nice properties must be trivial in a certain sense.